Here we want to find the this double integral here. And so for this double integral, first we evaluate the inside integral. So the inside integral is e to the x minus y dy. E to the x minus y, we can rewrite it as e to the x times e to the negative y. This integral is with respect to y, so e to the x will be considered constant. And this e to the x, because it's a multiplication constant, we can move it and place it in front of the integral. E to the negative y, the antiderivative would be negative e to the negative y. And then evaluate from 0 to 3. So in the place of y, we have 3, and then minus the lower limit of integral is 0, so in the place of y, we have 0. This becomes negative e to the negative 3 plus 1, e to the 0 is 1. And so this is the inside integral. And now for the double integral, replacing the inside integral with e to the x times minus e to the negative 3 plus 1. This integral now is with respect to x, and so this expression here is just constant, multiplication constant, so we can move it and place it in front of the integral. Antiderivative of e to the x is e to the x, and then evaluating from 0 to 3. So first, in the place of x, we have 2, so we get e squared. And then in the place of x, we have 0, e to the 0 is 1. And so this is the value of this double integral. For the function like e to the x minus y, we can also evaluate this double integral as follows. E to the x minus y is the same as e to the x times e to the negative y. The inside integral here is with respect to y, so e to the x will be considered constant. And so it's a multiplication constant, so we can move it and place it in front of the inside integral. And now look at the outside integral. The outside integral is with respect to x. This part right here, there's no x here. So we could think of it as a multiplication constant, so we can move it and place it in front of the outside integral. And then now evaluate each integral separately. Antiderivative of e to the negative y is negative e to the negative y, evaluating from 0 to 3. Then we get negative e to the negative 3. And then when we put 0 here, we get minus e to the 0, which is minus 1. And so it's the lower limit of integration, so it becomes plus 1. antiderivative of e to the x is just e to the x. Evaluating from 0 to 2, we get e squared minus 1. So this answer is the same as what we got earlier. Again, we can only use this alternative method for some functions. And so for other functions, we cannot use this alternative method just for some functions.